Hello and welcome back to another episode of Black Hole Battles game development here on Let's Code Physics. In a previous episode, I asked y'all for feedback about what to do about the option to have a drag force acting on the ship in the game. The dilemma is this: if you're in empty space, like we have here, which is looking more like space now, thanks to the new background from my brother, Kyle Blaine, of Kyle Blaine Plays. Go check out his channel, please. He is doing the artwork for this game. He has created this background for the space. The ships are still mine. I haven't gotten the ship graphics from him yet. And when I do, I'll be replacing those. So anyway, here's the dilemma, is that in empty space like this, there's nothing naturally there to slow you down. So when the player ship goes off into the black hole field. Oh, Kyle also sent me these new black hole designs. Don't they look great? They're very menacing looking for as simple a graphics as they are. They're very menacing looking. To naturally slow you down, so you're constantly overshooting where you wanted to go. So in order to get back up here, I have to first slow down and then accelerate in the other direction. And the thing is, that is physically reasonable, right? That is physically what you have to do in space when you are flying around in a spacecraft. If you want an example of that, just watch the scenes with is it Danny? No, it's David. Whichever Glover it is, the Glover son in The Martian. They talk about how they need to be accelerating instead of braking and all this stuff because you're constantly moving with respect to something. Oh, and I died. So it makes it more authentic, but it also makes it a bit more difficult to control and a little bit less intuitive. The other option is to add in a drag force. So, like for example, Unity already has a drag force built in. All I have to do is turn on the drag coefficient. My ship will automatically brake. So there'll be a force that's in some ways proportional to the velocity of the ship acting on it, and it automatically slows down. Well, I didn't slow down enough there, but you can see I was slowing down with respect to the black hole. And of course the black hole is pulling me in, so the drag force is not going to stop me from getting pulled in. But the drag force just makes it a little bit easier to control the ship. For one thing, it'll put a maximum speed on the ship, and it also gives you this auto braking function. So if I go way far off, and I haven't yet gotten the background to extend here, that's something I'm working on. I've got a video queued up for me to learn how to do that. You notice that I eventually come to a stop because the drag force is going to keep acting until your velocity is 0. The problem with that, well, there's really two problems with the way I just did it. The primary problem is that's not physical. There's not a drag force acting on you in space unless you're in an actual, nebula, and even then, I'm pretty sure it's diffuse enough to not significantly impact you. Or, as my brother pointed out on a comment, you can use the Star Trek inertial dampers, which are not really a thing. They're just a plot device so that the crew of the Enterprise doesn't end up smacked on the back of the wall when the thing goes to warp speed. But we could call it, auto braking or something like that, to where the ship is able to do that. But the other problem is I don't know what the formula is for this drag here. It says linear drag, but folks online, I looked at a couple of discussion boards, and people online can't seem to determine whether this is the damping force, F equals negative BV, or the full-fledged drag force, F equals 1/2 rho V squared CDA. And the important thing is, we don't know whether the drag force in Unity goes like V, the velocity, or V squared, velocity squared. I know that at low speeds, drag forces go like V, and at high speeds, drag forces go like V squared in the real world. But they haven't seemed to determine yet how Unity programs that in. And either way, if there's other stuff being attached onto this, I need to be able to calculate the drag force, because I need to be able to predict that in my look ahead, which you'll notice I've turned off because it's been useful, but it's a little bit irritating. Oops, I meant to turn that back on. Instead, I just highlighted it. There we go. So instead, it shows you where you're going to go, but it doesn't really give you a sense of how fast. So like right now, it's pointing upward because I'm going to continue, traveling upward. but it's still the same length there as it is here when I'm accelerating in this direction. So, oops, at viewer suggestion, I think I'm going to switch that back to the back to being a fixed amount of time ahead, so that way the longer the look ahead is, the faster you know that you're going. Excuse me, 1 second. Okay. Sorry for clearing my throat a bunch. I am doing these recordings now in the morning right after I eat breakfast, and so my body is still expecting more food and salivating. So I'll have to figure out a solution to that. So anyway, like I said, so if I incorporated the drag, I would have to I'd have to manually program it in so that I can include it in my force calculations for the look ahead. Now, which I'm going to turn off anyway because it's proven its usefulness. The problem is, do I go with what's easier for the player or what's an authentic physics experience? And I think what I've come down to is I'm going to make it an option in the game. So I'm going to set up a drag force, and the drag coefficient will be some externally controllable variable where the player in the options screen can say, yes, I want drag force, no, I don't want drag force. And I think that's the best way to go, because I don't want to frustrate players by not having an auto braking system if that's something they're used to. And we can certainly make the argument, that this region of space is filled with, some diffuse gas or something like that, or that the ship has an auto braking system. But I also, if they want the authentic experience / the additional challenge, then they should be able to turn off the drag force. And in fact, it might even turn into something strategic where on some levels a player has the drag force on and on some levels they don't. And, that sort of helps. I don't think that's an illegitimate physics learning experience. I think that's going to help them learn about what a difference the drag force makes and how it behaves and when they want it, etc. So I think that's the way I'm going to go. I have not yet figured out how to create an option screen, let alone a pause screen. And so what I'm going to do is I'm going to add in my own manual drag force with a drag coefficient, and then later on, when I've looked up how to add in the option screen, then I will do that. So we are looking to edit the ship controls. Let's edit that first. So I talked about the new background. I've also changed my script editor to Unity's default. I was using the Microsoft Visual Studio, which is good. It's a wonderful interface. It shows you lots of debugging issues and errors, but it takes forever to load. And, it even looks like it's going to crash my computer when it opens up. This mono develop that comes with Unity, it usually takes a shorter amount of time than this to load. But here it comes up. See, this even with it being delayed like that, it's already faster. And I suppose I should zoom in so that y'all can see this. There we go. So let's go back down to where we're calculating the force on the ship. Another thing I took out was this equilibrium point thing. I need to add in a check for whether it's already created an equilibrium point, and also whether it's actually within the cluster of black holes, because you can just get the ship really far away from the cluster of black holes and you'll get this whole line of equilibrium points, and that's not really the intention of the game. Of course, I also need to put in a barrier around the playing field, I think. All in due time, folks, all in due time. So here we need to add in the drag force. So for that, we're going to take force on the ship, and we're going to do plus equals, because that's the thing to do these days. We'll say negative, let's call it drag coefficient times, and then I need the ship's velocity. So I believe the best way for me to do that is, so we've got the rigid body 2D already set up, rb2d dot velocity. Awesome. And that's really all you need. This velocity is already a vector. And so when you multiply it by this, you're rescaling the velocity into the force, and you're having it point in the opposite direction of the velocity. So no matter what direction my ship is headed, this force that's getting added is going to be in the opposite direction. So I need to add in a drag coefficient. And I've learned that the red text on monodevelop means I haven't defined it yet. And so let's place that up here. Public static float drag coefficient. And I'll need to play around with this value, but let's go with 0. Well, let's go 0.1 for right now. And that needs an F at the end. There we go. Okay, yeah, so public static float drag coefficient equals that. Okay. So let's test that part for now and see what that does for us. I thought I pressed play. Are we pressing play? Oh, do I have a compiler error? I don't think so. All compiler errors have to be fixed. Okay, would you care to tell me what the compiler error is? Object type game object and destroy. That doesn't mean. All right, let's clear those. Unexpected symbol float. What line is that on? Line 76. 76 float V. Why? Oh, I never put semicolon there. Okay. Okay. Oh, yeah. Okay. Another thing I'm going to add to this is when you start out, you're going to be in a gravity-free zone, and there will be a lack of black holes around you, so that you can at least make it a few ship lengths before you are sucked into a black hole. Okay, yeah, this is working a little bit better because I'm not just accelerating away, and and there's that auto braking. See how I'm slowing down a little bit. Now, of course, I'm getting pulled in by this guy, but I'm getting pulled. Yeah, I'm getting slowed significantly. I'm not, flying off the edge of the screen. And of course, I still have my reverse thrusters and my forward thrusters. Another thing that'll be helpful on the ship, I'd like for whenever you're applying thrust, for the thrusters to light up either in the back or just off to the front of the tail, so that way you get a sense that you are thrusting forward or thrusting backward. Oh yeah. By the way, you notice this little parallax on the background. That's because the background comes in 3 layers. So if I zoom in on this guy here, this is really cool. This is not what I was planning to talk about today, but it's really cool how we figured out to do this. The background comes in 3 layers. So there is the background. I know that seems redundant, but that's the star field in the back. That's the black part right there. So I've got each of these set up as a quad, so as a pure just square. And then I've got the mid background above that. So if you take a look at the Z value here, this thing's at a Z of -2, and this thing's at a Z of 0, which is really cool because what it does is it gives it this natural parallax effect where one is going to look like it's traveling, faster than the other one, or at a different angle than the other one. So we've got -2 and 0. The ship is at 0. Actually, that shouldn't. If that's at 0, then this back should not be at 0. How is the? Oh! It's relative to the background group's location, right? So this is at 5, so you have to add 5 to everything. So this is actually at Z equals 5 back this way. This is actually equal at Z equals 3. And then this is the cool part, the front background. If you take a look, the front background, the little blue outline right here, is in front of, in terms of the camera, the black holes and the ship. So this front background at -7 plus 5 gives you -2. It's actually 2 units above, so closer to the camera than the ships are. And so if you watch, you can, like, this star right here is actually in that front background. Whoa. I also want to work in bonus points for a successful orbit around a black hole. If you watch, this thing's going to pass in front of the ship. Wasn't that cool how that passed in front of the ship? This one will do it too. If I can get the ship pointed in the right way. Oh, come on, guy. So yeah, anyway, I thought that was cool. My brother sent me this background in 3 layers. And when I learned how to layer them like that, I said, oh, one of those needs to be in front of the ship. And so you can kind of, yeah, you can see that. Well, let's just pretend you saw it. I promise it's there. Let's go back to the 2D view. There we go. Okay, awesome. And actually, I'm going to, for when I get this EP check, equilibrium point check back in, I'm going to need to put this down here because equilibrium point is a function of the black hole's configuration, not of this thing, not of the drag force. Okay, I think that worked out pretty well. Let's play around with the drag coefficient a little bit. Give it let's double the drag force. That's probably going to be too much. I think if anything, I would want to decrease it. Oh yeah, this thing is plodding along. See, part of it is this needs to be a navigation game where you're navigating the black holes and away from the enemy ship. And so you need to be able to make, you know, some pretty quick maneuvers. So I feel like the 0.2 is a bit too high. Actually, I almost feel like the 0.1 is a bit too high. So let's try 0.05. Oh, I hit F5. I'm so used to working in VPython. Speaking of which, this week I get to introduce a new generation of students to VPython in my introductory physics class. Today is the first day of classes. Here we go. Okay. I feel like that's getting a little bit too much back into the ship is flying around loosely everywhere problem. Okay, let's leave it at 0.1. That'll be something that as we play test it, I can fine tune. I'm kind of tempted to give the user an option of how strong the drag coefficient is, but I feel like that might turn into, you know, sort of gaming the system as it were. But you know what? That might not be such a bad idea. I don't know. Whatever teaches people physics, right? Okay, so that's awesome. So I want to get rid of this thing. I don't really need this right now. Oh, I was hoping to get a little something. Okay, let's just exit that. There we go. Okay, I can pull them back up if I need to. So I next need to incorporate that into the look ahead. Even though I'm currently not using it, I need to be able to incorporate that into the look ahead. Let's see. So I just need to grab that one line of code right here. Ship controls. Where did you go? Where did you go, drag code? Okay. Right, because there's all of this. And let's leave a note to ourselves. Add drag force. And I think I'm going to leave it as a linear drag force. I don't think I'm going to do the square drag force because that one can get that one gets complicated. Plus, it's one more calculation for the code to have to run. For the game to have to run. This is not just a code, Brian. This is a game. Okay, so we got the calculating the force. Here's the thrust. Here's the drag force. Okay, so here we're not calling it force on ship. We're just calling it force. Plus equals. And so I need to access ship controls dot drag coefficient. Can I do that? Is that legal? Okay, it knows what that is. And then I need the thing's velocity. So how am I accessing the ship's okay, it's parent. Okay, so I just need parent dot velocity. Parent is really cool because the look ahead is a child underneath ship. All you have to do is say parent and it finds it within the ship. It's really cool like that. I may as well add in a note to myself that we're adding the thrust here. There we go. Okay, cool. So this now incorporates the drag force into the look ahead trajectory calculation. Do I have velocity being updated? Oh, actually, no, I don't want it to be parent dot velocity. I want it to be vel, because my vel up here is this. Now, do I initialize vel? Okay, yeah, so I initialize vel as parent.velocity.x and parent.velocity.y. So that's the current. So the parent.velocity is the current velocity, and I need to be able to update that as the look ahead plots its trajectory. And so I've got vel adding the force divided by mass times time times delta time. Then we're updating the path here. Cool. And I do initialize. Yeah, I initialize path as 0 because it's relative to the parent, right? Okay, cool. So let's turn on the look ahead. Okay, cool. So yeah, that's showing it a bit more accurately. I mean, it's showing it accurately with the drag force added. It looks like I can almost make it around this guy. Okay, cool. And now the last thing I want to change is, so this this look ahead is going a constant distance, so it's a constant arc length, but it's not really giving me a sense of how fast the ship is going. So I guess I've got a couple options. I can either I suppose I guess I have a couple options. I could either make it a fixed time, and so the longer it is, the faster you're going, or I could do something with the appearance of it and make it like the wider it is, the faster you're going. But I don't know that that makes a whole lot of visual sense. So let's change it back to a set amount of time ahead. Let's see. So this is the number of frames to look ahead, path ahead. Okay, so let's search for where we use path ahead. Okay, yeah. So what I want to do is I want to change back to this for loop. So now it's for j equals 1, j less or equal to number of frames, j plus plus. And I think that's it. So do I have path ahead anywhere else? If path less, okay, yeah. So this one, let's have this be if j is less than. Actually, no, leave that just in case I want to change it back. Never get rid of good code. If j is, goodness knows we have enough non-working code on this channel. If j is less than the number of frames, there we go. Okay, yeah, that'll work. I don't think I used j anywhere else. All right, let's give it a try. Yeah, see, now this is the problem that I worry about, is that it's doing this jumping thing. But it is getting longer. Actually, I wonder if that jumping problem is really there, or if that's a screen draw error. But it is definitely giving me an indication of my speed. I just don't like that jumping that it does. Is there a way for me to... Okay, so the size is... No, the size should stay constant. Let's look at how far out it goes. Let's increment this thing forward. So it's jumping up. But see, now I'm not seeing it jump as I inch forward, you know, 1 frame at a time. So I'm thinking that's a screen draw. One way to find out is to actually build the thing, and then is to actually build the game and then run it and see if I get it there. So I'm going to do that. Depending on how long this takes, I might cut here. Let's play this. Yeah, I am going to need to buy the professional edition, I suppose. Okay, yeah, it's doing the same thing on the actual gameplay. Boy, this looks good when it's not in the preview screen. I mean, it looks good in the preview screen. Yeah, I'm gonna have to find out why it's doing, because see how it's so jittery like that? I'm not sure why it's doing that. And so that's something I'm going to have to look into and fix. That's I suspect that's a problem with how I have the... Well, actually, I wonder if the problem is that I'm looking forward amount of frames instead of a certain amount of time. Because apparently those are different. I was reading something on a discussion board, and it's actually different, the number of frames versus the time that passes. So let's do a public float time ahead equals, and let's say that we're going to look ahead 20 time clicks. So let's say time dot delta time. Fixed delta time? Can I not have a... Yeah, just delta time is fine. Okay. So we're going to call that time ahead. Okay, so let's do this. Let's keep this, copy it, and let's keep it commented out there. So let's call a new variable, a new counter. Let's call it time. Oh wait, that's already taken. Let's go with t, I guess. So we'll start t at 0, and we're gonna go t less than or equal to time ahead. How do I set up a... You know what? Rather than look this up, let's just do a while loop. Time, no, just time. Float t equals 0. Let's do while t. I'll figure out how to turn that into a for loop and then replace that, because I'm sure the for loop is more efficient. While t less than time ahead. There we go. It's okay that I start time at 0 because there's no actual time dependence, explicit time dependence in here. And then let's have this be if, again, comment this out, if t less than t ahead, time ahead, there we go. If t less than time ahead, then you calculate this. And then down at the bottom here, of course, somewhere in here, I need to add delta time to t. Okay, and so I need for that to go here. Yep. T plus equals time dot delta time. There we go. Okay, I don't see any red squigglies. That's fine. I'm not worried about those. Oops, no. Okay, there we go. All right, let's see if we get the same issue here. I do not get the issue because I don't see the look ahead at all. Maybe I didn't have enough, maybe I didn't put in enough time. That happens in life sometimes. You just don't put in the time. Yeah, it's there. It's incredibly tiny. Okay, so let's make that a little bit longer. Yeah, if I had 100 frames ahead, then this should be about the same order of magnitude. Let's see. And again, this is all to get rid of that jumping jittery part. If it doesn't get rid of it, then I may need to try something else. Okay. Not seeing it again. Let's check out our line here. Oh, this thing is only doing 2 points, and they're incredibly close together. Okay. Okay, so I thought about this problem all day. Well, maybe not all day. I did have some teaching to do. But I thought about this for over the course of the last 12 hours of my day, which was just a couple seconds for you. And I realized that I didn't understand the nature of this time.delta time value that I was using. And what it turns out is that time.delta time is the amount of time in seconds it took to complete the last frame. That can vary. That can be a different value because Unity updates its frames differently than it updates its time. And so when you want something to be consistent in terms of physics, you have to use this fixed update, right? So this function is called every fixed frame rate frame. So it should be used instead of update when dealing with rigid body, which we are doing. For example, when adding a force to a rigid body, which we are doing. And so what I had to do was change my instances of update to fixed update. I did that both here and in the ship controls just to be safe. I changed those to fixed update. I feel like the game's running a little bit smoother now. That might be a psychosomatic effect, but I think it's running a little bit smoother. But definitely the look ahead is behaving better. Another thing I discovered that I had a problem with was that I had set time ahead to be 100 up at the beginning, and I wasn't reinitializing it to 10 because I had, or to 100 like I had before, because I had this time equals, time ahead equals, time ahead times delta time. But I ended up getting rid of that anyway because that was still a little bit difficult to adjust. I went back to the frame formulation because now that I'm calling it within fixed update, it's keeping the frame rate consistent in terms of when it calls this thing. And so what I end up with now is, so I'm not doing the time base anymore. I'm doing the in frames instead. So I'm looking ahead 10 frames. I've still got time ahead and path ahead declared just in case I want to switch back to those, but I'll probably comment those out eventually. So right now it's looking 10 frames ahead. And so just like we wanted, the faster the ship is moving, the longer the look ahead trajectory is. So here I'm speeding up, so it's getting longer. I slow down and it gets shorter. And it's actually doing a pretty good job of predicting where I'm going to go. I'm finding it easier to sail in between black holes now. The one thing I need to do is bring this look ahead toward me a bit, toward the camera. So, and I think negatives are, negatives indicate in front of. So I guess this is a left-handed coordinate system. That's a bit weird. So let's put that as a -1, see if we get... It's still not being more visible. I'm not sure why that is. I'll have to play around with that a little bit. Because, obviously you want the look ahead to be more visible. Like right now it's not visible. But I'll probably adjust that whenever I get the ship graphics in from Kyle and the trajectory graphics in. See how it's getting longer as I'm going faster, and then as I slow down, it gets shorter. I need to, I just ran into 2 black holes in a row. But yeah, this makes it a lot easier to play. I think I'm going to stick with, what value I changed the value to 20 over here, so I should probably change it to 20 on the code. 20 seems to be a pretty good length. 10 was a little short. 50 was definitely too long. 20 seems to be a nice compromised. Oh, and of course I just changed the script while running the program, so it crashed on me. But yeah, this seems to work out pretty well. I'm going to work on figuring out how to get the line in front of the ship. I'm not entirely sure why it's not in front of it right now, why you can't see it in front of it. Because it sure does seem like it should be above it. And in fact, from this angle, it looks like it is. But then when I go to 2D... oh, you know what? I wonder if I've got to do something with the camera. So like if I turn that off... No, that's in front of it there. Yeah, I'm not sure why the ship is appearing in front of it. Anyway, I will play around with that. Major success today. We got the drag force. We got the trajectory working. Hooray! Thank you so much for watching. I'll see you next time. Bye-bye.